Hi everyone. Well, we did these 5 in class, and now I'm going to talk about the trig limits and the squeeze theorem. So, trig limits, these are 2 limits that you have to have memorized. You can see if you just plugged in the 0, you'd get undefined, which you might want to say the limit doesn't exist, but these are both proved using this squeeze theorem, which I'll explain in a minute. But once you prove it using the squeeze theorem, then you memorize these facts and you just get to use those facts in your math. Just because it has trig doesn't mean you're going to use those. It's just if it appears that way. And I will explain that as we get to it. But with trig, I'm on line paper here, so I'm going to do example 3a, the limit as theta goes to pi over 4. So just like with other limits, what do you always try first? You always try direct substitution. Yeah? So we're going to try to directly substitute pi over 4 into here. So we have pi over 4. So it's kind of neat. You can see theta is here instead of x, so you can do limits with theta or with different variables. Like here it's t. It's not just x and y. So instead of theta, I'm replacing theta with pi over 4. You know, just to review, theta is a variable and pi is a number. So don't think they're the same. They're not. Theta is a variable like x and pi is 3.14. You know. Okay, so theta was replaced with pi, and now we're going to do times the tangent of pi over 4. All right. Tangent of pi over 4, do you have that one memorized? It's one of the easier ones. Let me draw I only draw what I need. So I only need pi over 4, which is 45 degrees. Are we in the window? Yeah. What's the coordinate point for pi over 4? Square root of 2 over 2, square root of 2 over 2. Tangent, the definition of tangent is y divided by x. So if we take this y value and divide it by this x value, aren't those the same? We would get the number 1. Right? So the answer here to A, we're going to have pi over 4 times 1. So the answer is pi over 4. See that? So direct substitution, we just evaluated the limit by direct substitution. All right, let's do B. B is a limit as theta approaches pi over 2 cosine squared all over 1 minus sine squared. Nope, sorry, 1 minus sine. All right, remember trig identities? So we should always try direct substitution first. Sorry, I already know the answer, so sometimes I cheat. I'm sorry. What is the sine of pi over 2? So if we plug in pi over 2 into top and bottom, let's look at pi over 2. Pi over 2 is 90 degrees, right? Pi over 2 is up here. What's the coordinate point up here? We have 0, 1. So the cosine is 0, so we're going to have 0 squared over 1 minus, the sine of pi over 2 is 1. So 1 minus 1 is 0, and we get undefined. Now you cannot write does not exist. We have to do more math. Anytime you have a 0 in the denominator of a limit, that means do more math. Do math on it. Okay? So what are the techniques? We've used factoring, rationalizing, complex fractions, but here, guess what technique we're going to use? We're going to use the trig identities. What? Identities. Do you remember those? Remember we spent weeks on them just to do this one math problem. Now, what are the trig identities? Which one do you think we're going to use? Okay, do you remember the most famous, the Pythagorean theorem one? Do you remember that sine squared plus cosine squared equals what? What does that equal? Remember that equals 1? Yep. So let's substitute out cosine squared. What would we substitute out cosine squared for? We need to get this by itself. Yeah? Can we move the sine squared to the other side by subtraction? Then cosine squared equals 1 minus sine squared, and we're going to substitute that out in the numerator. Okay, so instead of cosine squared, we have 1 minus sine squared all over 1 minus sine. All right, why do we like 1 minus sine squared? 1 minus sine squared, is that a squared minus b squared? So can that be factored like this? Yes, it can. So we can factor that numerator because 1 is a perfect square and sine is a perfect square. Do you know what my favorite part of calculus, the year of calculus is? The day where I have to stop writing the limit, because I don't have patience, you guys. I don't like writing it every single time. I bet when I was a student, I got marked off for that. Here we go. We factored. Fantastic. And what do you notice? What happens? Common factor, 1 minus sine, 1 minus sine. Now can we plug in pi over 2? Yes, we can. So pi over 2, so once you plug it in, you don't have to write limit anymore. So we have 1 plus the sine of pi over 2. Do you know what that is in your head, or do you need to look back here? Sine is y value, so sine of pi over 2 is 1, and we did all of that work. Oh, I thought the answer was going to be 0. It's not. It's 1 plus 1. Yeah? Cancel. Negative. 1 plus 1 is 2. Woo! Isn't it exciting when you get 2? See, I thought we were going to get 0, and I would be upset. So what did we learn here? You know, sometimes you can do direct substitution, but sometimes you have to use trig identities. Are they ever going to be as hard as they were in pre-calculus? No, they'll never be that hard. It's always like Pythag, okay? One of the simpler ones. All right, part C. Let's see, let me write it down. The limit as t approaches 0, sine of 3t. Okay. What should scare you is like how basic this is, and you're like, oh, it's so simple. I don't know what to do. I can't factor it. There's no identities. Okay, so what we're going to do is we're going to use this fact here. Sine x over x is equal to 1 when the limit's going to 0. So here we have a limit going to 0, but we don't have sine of just x. We have sine of 3x. So watch what we're going to do. All we're going to do is we're going to multiply the top and bottom by 3. We are not pulling this 3 out in front. We're multiplying the top and bottom by 3. So now we have 3 sine of 3t all over 3t. You with me? Okay. Why did we do that? Because this, the limit of this is equal to 1. Okay? How do we know that? Well, so hold on. Let's start here. The answer is 3 times 1, which is 3. Okay? I'm still here. All right. That brings us to, now why is this equal to 1? Because I told you so. Oh, shoot, I wrote 0. That's wrong. Because I told you so. I'm teasing. You know that, right? Never supposed to accept that as a math teacher. Okay, maybe I should have started with this. I don't know. Here we go. Why is this limit 1 and why is this limit 1? Well, it all has to do with the squeeze theorem or the sandwich theorem. Okay, it's also called the sandwich theorem, but officially in calculus AP, it's called squeeze theorem. So what this says is if you have a function in between another function, do you see how this one's in between? It's being squeezed by these two functions. Let me show you what that looks like on the graph. And we'll call this x and we'll call that y because that's what they're called. All right, one thing I want to tell you is that the limit as x approaches c of f equals L And the limit as x approaches c, so same y value, of h is also L. What? Okay, so what do you propose? If this is L and if this is L, what does that limit have to be? It's squeezed in between. Let's draw a picture. Okay, let's say that this is F. That's F. Guess what? What does F has to be less than these two? So that's not a good F, right? F has to be less than. So we're going to say this is F. F. And this is H. Got it? So this would be C. And this here would be L, the limit. Okay, say they're getting really, really close. And then where is G? G is between F and H for all of it, its whole life, its whole existence. Eek, eek. Okay, this is G. Do you agree that this picture matches this sentence? H of x is greater than G of x is greater than F of x. And if the limit of F is L and the limit of H is L, lo and behold, what does that conclude? Thus, what does the limit of G have to be? The limit of G must equal L also, so it's squeezed together. This is on page 65 of your textbook, and you can look at an example. All right, sorry about that. I'm going to attach another video. This is officially the squeeze theorem for any function, and there's a really good proof on Khan Academy on the squeeze theorem that proves that the limit as sine x over x equals 1. So that's going to be a separate link for you to check out. And you can copy that here. You can just go with this and just memorize that. Thanks for watching.